So here our aim is to do the what? The Laplace inverse. But there's one hindrance here. If you have it in this form, even if you are using the table, there won't be a single function to help you to describe all these, right? So one way that help us to solve this is what we call the partial fraction. There are different ways of doing it, but one way is using the what they call partial fractions, right? So it breaks down this fraction, what do you call it? Yeah, this fraction here into multiples. Then we add them, and then you can transform the individual ones, which will still mean the same thing, right? So this form, if you are familiar with partial fractions, we know that here we will have to break this one down to have different what's the name? To have different fractions, right? And then how we go about it is that we have to find the roots of that one, right? So let's see. So to do that, we have to find the roots of the denominator, right? So the roots are, so here we know clearly the roots are -2 and what? -1. But there's another catch. You see that this is you can skip this part if you're already good with that, right? There's a, what do you call it? A polynomial of order 3, right? And then if you have something of that, so mean that you need what? You need 3 roots, right? But here's the case: if you are using a calculator, fx 991 years or whatever, it gives you 2 roots. It doesn't state, meaning that you have a repeating root, but it doesn't state which of them is repeated, right? There are 2 ways of going about it. This to find which of them is the repeated, right? So in this equation here, we know the b is what? So now we are using this equation. So minus, and we know the b is what? 4. So -4 minus, right? And the roots are minus, if you add them, that's -2 -1. Right, so we know the repeated root is what? Equal to -1. Let's try the next equation too. Right, this is minus d, and we know from this equation here that the d is what? 2. If we multiply the root -2 times -1, it gives a -1. So clearly it's confirmed that the repeated root is this -1 here. It may happen that you get some case like that, so that's why we do this, right? So we have the repeated root is the -1, so s plus 1 repeated to square, right? And then here we have what? S what's plus 2, right? So this is a simplified form. So then if we are doing the partial fractions, this is what happens. X of s, you're familiar with this already. We know that this whole equation will be equivalent to something of this form, right? We have a, right? And then here we have of s. So for you to check even the number of constants that you need, you can look at this. This is 1, you need 1 from this. And from here you need 2, makes it 3, and from here you need that one, making it 4, right? So a on s, right? Plus, and even for this, there are ways of doing it. And here we have on what? S plus 1. And then c, we have what? S plus 1 squared. And then here we have what? D, or s plus 2. Right, so this is the general form. That will mean that you have to find the constant a, b, c, and x, right? And we know all this is equivalent to this. Right, so you have to find a way of doing it. You set x to whatever value that you want, but this essentially is equal to, let's see, a. Oh, this is a simplified form, but we can't equate this to yet, right? Yeah, okay, this is actually equivalent to this, right? S plus 1. And then you set the s to different values just to make sure you're able to find. And we are seeing all this is what equivalent to what? 2 because we have it in the same format as this, right? Yeah, so let's do it one by one. When we can set the values that you set s2 is just to make sure that the other ones tend to 0, so you can find the rest, right? Let's see. From this here, mean that we can set, let's see, let's start with, if we want to turn this side to 0, we can set s to be equal to, what do you call it, -1, right? We can set s to, so we can have -1, right? And from this to, we want all this to tend to 0, we can set s to be what, -2, right? This as well. Whenever we set s to be either -1 or -1 or -2, it will definitely be 0, right? So, but we can set s to 0, right, from here. So we can set s to 0 as well. And then from here, whether we set it to 1, -1 or -2, we'll get it to be equal to 0. So we have to find a way around that particular one, right? Next is equal to, oh, this is s, this one. When s is equal to -1, right? So we will have, oh, -1 as well, then this one too will tend to 0, right? Fine. So that will mean that we'll have 2 being equal to, let's see, c is bracket 1, or into bracket, oh, it's actually, we said -1, right? Okay, -1, right, times -1 plus 2, and we can get our c. So let's see. So definitely we end up with c being equal to -2. So basically that's how we find the constants, right? So a is 1. So that will mean that the whole equation of this x of x in the partial fraction form will be equal to something similar to this, but with the numbers replaced, right? The the unknown constants replaced now that we found them, right? So let's see. And then we have 1 plus b is a positive. B was b. Looks like we haven't found b yet, right? So the way we find b is that now that we found all these constants, we put everything in and then we simplify, right, to find b. And there are cases where frankly this actually happens, where you can't find b directly, right? So we actually look for the original equation, right, and we put the constants in and then we expand, right? So this, the only thing we don't know is b, right? So let's put it here, b on s plus 1. And how we go about this is that we put everything in and then we cancel out and then see what happens. So that's how we're going to go about it. So here we've looked at two unique cases where the roots are repeating, where you can't find it directly, and the case where you can't find one of the constants by just doing find s is equal to this, s is equal to 1, 0, whatever we do, right? Fine. And then we're saying that all this is equal to 2. Right, so let's see. We know that a is 1, right? So when we expand this, we get what? So we are going to expand this step one by one. So when we expanded this, we will get, let's see, s cubed. So let's do one by one. minus s. So this is taken care of. Fine. So now I'll just have to cancel out and see what's happening, right? So it's like I'll be subtracting. Fine. So here, and we know all these, all this side, wait a minute, all this is equal to this, and they're equal to 2, right? Fine. So then, when we compare this, we clearly see that this is taken care of by this, right? Where we have plus 4s squared. Plus 4s squared is taken care of minus 4, there, yeah, minus 4s squared, right? And here we have 5s. Let's see. Oh, so we overlook something. So this one here, this is this first one, right? And this one here ends up being this one, right? So we skip something in the expansion, right? And that is, when we expand this one, this is minus 4s, sorry, minus 2s squared. This should be minus 4s. Fine. So yeah, so then 5s, right? We want to consider this is minus 4s minus s, that consider 5s. So we're only left with 2, which is equal to this 2. So what that actually means is that on the left hand side we have bs into bracket s plus 1, right? And we have what, s plus 2, right? Plus 2 being equal to 2. And then we know this can take care of them. So that would mean that all this expansion here is equal to 0. And then we've already found when s is equal to minus 2 and s is equal to minus 1 when s is 0. So definitely we can see that b is equal to 0, right? So this whole thing here is taken care of. So this goes out and the whole simplified equation is this, right? So let's copy this. This is what x of x, and then this whole thing tends to 0 because b is what, 0, right? So this is 1 on s, this is 1 on s, and then this is what, x of s being equal to this, right?